Hello viewers, in today's class we are going to discuss one important special definite integral, right? So here we have to find the value of this definite integral which is from 1 to 16 dx over x raised to half plus x raised to 1 over 4, right? So here the limits of integration are from x is equal to 1 to x is equal to 16, and here let us call this integral as I, right? And here we see that our integrand is of the type 1 over x raised to m over n plus x raised to say p over q, right? So here the integrand is of this form, that is 1 over x raised to m over n plus x raised to p over q. M over n and p over q are the rational numbers, right? So now in such cases what we do, we find the LCM of n and q, right? Here we have m over n and here we have p over q. So what we will do, we'll find the LCM of the denominators, that is n and q, right? So here we see that the value of n is 2 and the value of q is 4. So the LCM of 2 and 4 is simply 4, right? So once we have found out the LCM of 2 and 4, we'll make use of the substitution method. So now what we will substitute, we'll substitute x is equal to t raised to 4, right? Suppose the LCM of n and q is say r, right? Then what we will we'll put x is equal to t raised to r. So here the value of r is 4, which is the LCM of n and q, right? So now we have x is equal to t raised to 4, and we can write dx is equal to 4t cube dt, right? And let us change the limits accordingly. So when x is 1, then the value of t raised to 4 is 1, which implies that t is equal to 1, right? And when x is 16, then we have the value of t raised to 4 is 16, which implies that t is equal to 2, right? So when x varies from 1 to 16, then t varies from 1 to 2, right? So now this integral I can be written as t is equal to 1 to 2, and for dx we can write 4t cube dt, and x raised to half, we have t raised to 4, and here we have half. Then we have x is equal to t raised to 4, then we have 1 over 4, right? So now this integral is from 1 to 2, 4t cube dt, and here this term becomes t square, and here we have simply t, right? And we can cancel out 1t from numerator and denominator, so this integral now becomes 1 to 2, and we have 4t square dt over t plus 1, right? So now to solve it further, what we can do, we'll take 4 outside, and we have the integral from 1 to 2, and now we are left with here t square, and t square can be written as t square minus 1 plus 1, right? And here we have t plus 1, right? So we have expressed t square as t square minus 1 plus 1. This minus 1 and this 1 get cancelled, and we again get the same integral. So what we are why we are doing this? Because we are going to split this integral from this point, right? So now I is equal to 4 times integral from 1 to 2, and here we have t square minus 1 over t plus 1, and then we have plus 1 over t plus 1, right? And now here we can further simplify it as c t square minus 1 can be written as t minus 1 t plus 1, and in the denominator we have t plus 1. So now this t plus 1 and t plus 1 get cancelled, so we are left with t minus 1, and here we have 1 over t plus 1, right? So now this integral reduces to this one. So now here we have 4, and the integral of t is t square over 2, and the integral of 1 dt is simply t, and the integral of 1 over t plus 1 is log of t plus 1, right? And the limits of integration are from 1 to 2, right? So now here we can simply substitute the limits, and we have 4, and when t is equal to 2, we have here t square, that is 2 square is 4 over 2 minus 2 plus log 2 plus 1 is 3, right? And when t is equal to 1, we have 1 square over 2, that is half, minus 1, and here we have log of 1 plus 1, that is 2, right? And now I can be written as 4, and here we have 2 times 2, so we have 2 minus 2, which is 0, so we have simply log 3, and here we have half minus 1 is minus half plus log 2, right? And this can further be written as, so we have log 3 and minus minus plus, so we have half, minus plus minus, so we have minus log of 2, right? So now here we can write it as 4 times half, and here log 3 minus log 2 can be written as log of 3 over 2, right? Because we know that log m minus log n is equal to log of m over n, right? And if we multiply these two terms by 4, we have 2 plus 4 times log of 3 over 2, right? So viewers, the value of this integral is given by 2 plus 4 times log of 3 over 2.